Two, this week we are focusing on energy transfer. We've got a couple of learning targets for you this week. Hopefully, all of our conversations about energy will combine and you'll be able to see how they connect a little more this week. So, we're hoping by the end of this week you'll be able to identify transfers in everyday objects with energy and realize that energy can never be created or destroyed on its own. So let's start at the very beginning with who figured all this out, and that's Albert Einstein. A couple of huge things that he discovered and pieced together is that energy is something that cannot be seen, it's invisible. And we've talked about that for a couple of weeks now. That's not new to us. But he also pieced together that energy is never created or destroyed. It is simply transferred from one form to another, and that's the energy transformation. He put this together in a scientific law, which means that that is always true. We know that laws in the state in on the road, they are always true. And so in a scientific law, it means that it has been proven over and over again, and it's never going to be disproven, and that is the law of general relativity. So let's quick review all those different types of energy. I don't have all of them on here, but we obviously have kinetic, moving energy, potential, our stored energy in things that are not moving, heat or thermal energy, that release of heat and the temperature that is going on in objects, chemical energy, that's stored energy that is going to be transferred either in the food you eat, in batteries. Light energy, also called electromagnetic, but we'll be able to use light instead of electromagnetic because I also want you to pull out from electromagnetic sound energy. Also travels in waves, two different types though. And then electrical. I feel like these are going to be the biggest energies that you use, but do not be afraid to bring in nuclear energy if you're talking about the sun. Bring in any of the types of energies that we've talked about so far as you're thinking of your own types of energy transfers. So, what an energy transfer looks like is us tracing it to how the energy is transferred or pushed from one form into another. So let's think of a stove. We all have a stove. We've all been cooking more than we probably are used to. Not all of us, but some of us. And so if we start with a stove, we have to plug it in, right? When we plug in that stove in order to get it to work, we're starting out with electrical energy. That energy is then going to be transferred into all of the components of the stove. This can go into heat energy, which can either be in your oven or on your stove top, and that's going to allow you to cook some of your favorite things, like possibly macaroni and cheese. So think to yourself, if you've got macaroni and cheese and you are going to use that in your own body, remind your brain, what form of energy is that? Did you say chemical? I hope so, and if you didn't, keep reminding yourself, food equals chemical. Batteries also equal chemical, but please don't eat those. So let's look at more objects. Let's look at the computers that we're learning on right now. They can have so many different, please don't think that you're limited to these three energy transfers, but once you've plugged them in, I'm going to take electrical away because we know we plug it in. Obviously, it's going to start there. Then we've got mechanical. That can be going on with you typing on it, you moving your mouse, you moving your cursor. All of those things are going to cause the pieces of your computer to be from not moving to moving, including both, again, potential or kinetic, which together equal mechanical. We also have light energy coming off of there. You can see the light, otherwise you wouldn't be able to see what was on your screen. And finally, we have heat. If you touch your screen right now, you can feel the heat coming from your computer. Let's try another one. Let's think outdoors. Try and get outdoors. I'm going to keep saying that to you. But if we think of a tree is going to start being able to grow because of light. It needs that light for energy. So light is going to be its main source, along with water, obviously. From there, photosynthesis is going to occur inside that tree. That's a form of chemical energy. It's transferred into chemical in order to allow that tree to grow. And you may not think of it, but heat is going to be released between this transfer of light and chemical. That's also going to come in the oxygen that it's going to give us so that we can continuously have healthy air outside. Now let's think about your cell phone that you're probably spending too much time on. I know I am. Okay, our cell phones aren't always plugged in. They run off of batteries. So this is going to be that chemical transformation. When we are using it, think about it. Connect it to your computer. What other forms of energy are you thinking is going to be from your cell phone? Did you say light and heat? I hope that you did, because think about it. You're not going to see your screen without light, and you know if you're spending too much time on your phone, it starts to feel hot. If you get to that point, you should definitely be stepping away a little bit more. Okay, now let's think of a car. With our cars, they are going to run in very similar fashions, no matter what type it is. Even if it's a battery, it's still going to run off of chemicals. So whether you're using gas or an electrical car, a chemical reaction is happening for that car to work. As it's going, you've got mechanical energy traveling through. It's kinetic if it's moving, it's potential if it's stored, if the wheels are moving, if the gears are moving, if the engine's moving. There are some of you that could teach me way more about cars than I know. I can't help you there. But finally, do you ever feel the top of the hood once you have stopped the car? It obviously feels warm. Heat is also being released. So let's think about this. Are you noticing a theme with every single one of these transformations? If you are, tell somebody around you. Did you say heat? Because every single time an energy transformation is happening, heat is released. It's never going to be lost. The energy that you start with, it's not going to be as strong as in the end, but some of it is always converted into heat energy. So what I want you to do now is to think about, are you able to think of an everyday transfer as you are thinking back to the examples we just went through? Are you able to connect some of the energies that you've been talking about now since last week? If you are and you're feeling confident, I want you to head over to Flipgrid and I want you to explain an example of some object, doesn't matter what it is, in your house, and explain to me at least 3 energy transfers from that object. If you're still feeling confused, either go back to the textbook or re-watch this and see if that'll help you out. I know that you've got this, and if you have questions, please continue to ask.